That medieval fortress on the hill, complete with battlements and a turret, never held a single soldier. It held water. Across the 19th century, engineers hid vital tanks of 100,000 gallons inside stone towers dressed as castles, some rising over 180 feet. In 1855 alone, cities poured fortunes into disguising pipes as monuments. They fought fires, powered factories, and fed 1 million taps. So why did we tear so many down? The answer starts with the secret these fortresses were built to hide. Behind every Gothic arch sat a trick so simple it feels like cheating. Water does not need a machine to pressurize a city. It only needs to be lifted high enough, and then gravity does the rest for free, forever, without a single moving part. Raise water into a tank on top of a tower, and its own weight pushes it down through the pipes below. The higher the tank, the harder the push. Engineers measured this with brutal precision. Every 2.31 feet of elevation yields roughly 1 pound per square inch of pressure at the bottom. Do the arithmetic and the castle towers make sense? A tank sitting 100 feet above the street delivers about 43 psi at ground level, enough to drive water into upper floors and out of fire hoses without any pump running. The stone was decoration. The height was the engine. But height alone did not explain why cities trusted these towers over the alternative. To understand that, you have to look at what came before elevated storage and how badly it failed at the worst moments. The early 19th century did have machines to move water. They simply could not be relied upon. Those were steam pumps, which spread through city waterworks in the 1830s and 1840s. A boiler drove a piston. The piston pushed water into the mains, and for a while the taps ran. Philadelphia's Fairmount Waterworks, opened in 1815, first tried steam engines before switching to water wheels by 1822, precisely because the boilers were too temperamental to trust. A single engine there could consume nearly 10 tons of coal a day, and a burst boiler in 1818 had already killed 3 men and shattered the surrounding building. But a steam pump only pressurized the system while running, and steam pumps stopped for 100 reasons. When they stopped, the consequences were catastrophic. Pump failures left the mains empty precisely during peak demand, when everyone was drawing water at once. A boiler that lost its fire needed hours to raise steam again, and a cracked cylinder could sideline a station for days while foundries cast replacement parts. And peak demand had a terrible habit of arriving with fire. A blaze breaks out, hundreds rush to draw water, the pump strains and fails, and the hoses go limp against the flames. Elevated storage solved that nightmare with a buffer nothing else could match. A full tank in the sky did not care whether the pump was running or broken. It held its pressure through the night, through breakdowns, through the exact emergencies that emptied pumped mains. The tower was insurance written in gravity, and cities learned to depend on it. No single event burned that lesson into public memory like what happened in Chicago. One structure stands above all others, and it earned its fame by surviving the fire that leveled a city around it. It became the symbol of an entire age of engineering. The Chicago Water Tower was built in 1869 in Gothic Revival limestone, all pointed arches and crenellated stone. It rose 154 feet and enclosed a 3-foot diameter standpipe that steadied the surges from the pumping station across the street. It was designed by architect William W. Boyington, a man who understood that infrastructure could be theater. The same Boyington would later design the Illinois State Capitol Dome and Joliet's State Prison, but this modest waterworks became his most enduring work. He gave the city a working standpipe wrapped inside something that looked lifted from a European hillside. Then, history tested it. In October of 1871, the Great Chicago Fire swept through the wooden city and burned nearly everything in its path. Beginning on the night of October 8th, the flames raged for roughly 30 hours, killed an estimated 300 people, left about 100,000 homeless, and destroyed some 17,000 buildings across more than 3 square miles. When the smoke cleared, the water tower still stood, scorched but intact, a stone sentinel amid ruins. That survival was luck as much as design, but it did not matter. The image of the tower standing alone made it legendary. That legend hardened a conviction already forming in engineers' minds. If a tower had to be fireproof and sit in the middle of a growing downtown where land was precious, it might as well look like something worth having there. Function demanded stone. Stone invited ornament. Ornament justified the footprint. So the Chicago Tower was clad in yellow Joliet Lamont limestone, a warm, honey-colored rock quarried nearby. The stone came from quarries along the Des Plaines River Valley, barged and railed into the city by the ton, and masons dressed each block by hand to raise the crenellated parapet. Its battlements and turrets deliberately echoed medieval fortress design, a visual language everyone recognized as permanent and dignified. The height that gave water its pressure did double duty as civic pride. The city was not just storing water, it was announcing itself. If American cities treated their towers as proud monuments, Europe treated theirs as competition. Across the Atlantic, the same physics produced structures that dwarfed their American cousins, taller and more elaborate, as though each town were daring the next to build higher. Genk's water tower in Belgium and others across the continent pushed past 50 meters into the sky, landmarks visible for miles. Germany alone raised thousands of them. The brick Wasserturm in Mannheim, completed in 1889, climbed 60 meters and anchored an entire ornamental plaza built around its base. Many wore ornate brick and decorative rooflines that turned a utility into a signature on the skyline. Inside, standpipe towers concealed vertical iron pipes running through the masonry, the plumbing hidden behind the pageantry. That hidden plumbing did more than pressurize kitchen taps. The towers doubled as firefighting arsenals, holding a reserve of pressure hand-pumped engines could never sustain. When a hand crew tired, the pressure sagged. A tower never tired. Its reserve tanks fed hydrants directly during major blazes, pushing water while men were still hitching their hoses. That constant pressure changed the arithmetic of fighting fire. With a tower behind them, crews could run multiple hoses simultaneously without starving one another, surrounding a burning building instead of choosing a single point of attack. Cities noticed the difference in their ledgers. Fire insurance rates dropped in cities that could guarantee reliable pressure. The National Board of Fire Underwriters, formed in 1866, would later grade a city's water supply as a fifth of its entire fire defense rating, so a dependable tower translated directly into lower premiums for every property owner beneath it. Where firefighters saw a lifeline, industry saw a workhorse. The same towers that saved neighborhoods from flames kept the machinery of the industrial age turning, day and night. Factories leaned on that steady column of water as heavily as any fire brigade. Mills required a steady, high-pressure supply to drive processes and cool boilers around the clock, and a tower delivered it with monotonous reliability. The tanks smoothed the difference between day and night usage, storing water when demand fell and releasing it when the machines woke. Textile mills in Lowell, Massachusetts, and breweries across Milwaukee kept their own towers for exactly this reason, refilling them cheaply overnight when pumping was slack. And out along the tracks, Rail depots used water towers to fill steam locomotives, the whole transport network drinking from the same elevated principle. A single mainline engine could swallow 10,000 gallons between stops, so towers dotted the rail lines every 7 or 8 miles, spaced to the thirst of the machines they served. So the practical case was overwhelming. Fire, factory, and railroad all depended on the tower, which raises the real question. If the function was so valuable, why bother with the limestone battlements and Gothic turrets at all? A plain tank on plain legs would have held water just as well. The decorative shell was partly camouflage and partly confession. Cities were embarrassed to build ugly infrastructure in the middle of their finest districts. A raw iron tank looming over a boulevard read as an insult to a proud downtown. Municipal pride demanded that even the plumbing wear a respectable face, so the plumbing dressed up. Gothic and Romanesque styles dominated tower design from the 1850s through the 1890s, giving engineers a vocabulary of arches, spires, and fortress walls to hide behind. The towers were framed as civic monuments rather than utilities, presented as ornaments the city had chosen rather than pipes it had been forced to raise. For half a century, the disguise held because the physics behind it had no rival. And then, quietly, a rival arrived. It did not attack the towers directly. It simply made the reason for their existence disappear, and once that reason collapsed, the stone castles had nowhere to stand. The rival was the pump, reborn. Electric centrifugal pumps matured in the early 1900s, and unlike their wheezing steam ancestors, they were compact, efficient, and dependable enough to run continuously. Backed by the spreading electric grid after 1900, they drew power from central stations rather than on-site boilers, and a modest motor could hold pressure that once demanded a coal-fired engine room. They could hold pressure in a system directly, hour after hour, without needing a mountain of water suspended in the sky as backup. That capability rewrote the whole logic. Pressurized mains no longer needed gravity storage downtown, because the pumps themselves maintained the pressure the towers once guaranteed. Where new elevated tanks were still built, they shrank into plain steel and concrete, cheap and functional, stripped of every pretension. The Chicago Bridge and Iron Company began stamping out riveted steel tanks by the thousands, bolted onto bare lattice legs and painted with a town's name instead of dressed in carved parapets. The castle disguise had lost its purpose along with its physics. An obsolete monument is still a monument, and that turned out to be the problem. Once the towers stopped earning their keep, their ornate stone bodies became burdens. Cities that had once celebrated them now looked up and saw only expense. Maintenance of a stone tower cost far more than a simple steel tank, all that carved masonry crumbling and needing repair for a function that no longer existed. Worse, the towers sat on prime downtown land, the most valuable real estate in any city, and that value created relentless pressure to demolish. A useless castle occupying a corner worth millions was an easy target. Many were razed through the mid-20th century, their limestone hauled away. In Chicago itself, plans to widen Michigan Avenue in the 1910s and again in the 1940s repeatedly threatened the old tower, and only public outcry kept the wrecking crews at bay. But not everyone watched the demolitions with indifference. As the wrecking crews advanced, a new kind of resistance rose to meet them. People who saw in the towers not dead machinery, but living heritage worth defending. They fought to keep the survivors standing. The turning point came in recognition. In 1969, the Chicago Water Tower was designated an American Water Landmark, an official acknowledgement that the structure mattered as history, even after it stopped mattering as plumbing. Preservation movements grew steadily from the 1960s onward, reframing the towers as monuments to save rather than obstacles to clear. And where demolition was avoided, imagination followed. Adaptive reuse turned old towers into homes, galleries, and offices, giving the empty shells a second life. That second life carries a quiet irony, and it is the heart of everything these towers were. Today, the surviving castle towers are prized precisely for the disguise that once made them practical. The stone dressed up to justify a water tank is now the only reason anyone kept the tank at all. Converted towers now serve as apartments with astonishing views and viewing platforms open to the public, spaces people pay to occupy. Their masonry outlasted the very technology it was built to hide, the pumps and pipes long gone while the walls remain. They stand today as monuments to a vanished water logic, fortresses guarding an emptiness where pressure once lived. And that is the truth the battlements were always telling, if we had known how to read them. The castle look was never fantasy or vanity for its own sake. It was engineering pride cast in defensible-looking stone, a real machine wearing the costume of a stronghold. The battlements were decorative, never defensive, incapable of stopping an army, and never meant to. The true fortress was the pressure reserve inside, the silent column of water ready to fight fire and feed a city at a moment's notice. Form followed both physics and civic ambition at once. That is the whole story of these strange stone giants. They were, in the most literal sense, fortresses built to age-old waiter. They solved a problem so completely that we forgot the problem existed, and then we nearly forgot the towers too. The ones still standing survived by becoming beautiful once their usefulness ran out, which may be the best fate any piece of infrastructure could hope for. If you enjoyed uncovering the secret inside these stone castles, consider subscribing so the next piece of hidden history finds its way to you.